Alright, so we want to find this definite integral. It's the integral from 0 to 2 of 4x dx. So what we're going to do is write our equation, the limit as n approaches infinity of the sum from I equals 1 to n of f of si delta x. And that's going to be our limit that we need to evaluate. So now we have to start figuring out what things are. Now we know that delta x is b minus a over n. We know b is 2 and a is 0 just from how this integral is set up. And n, remember, for this type of problem we're going to leave as a kind of variable. Or you can think of it that way at least. So we're going to leave this, so that's going to be 2 minus 0 over n, or 2 over n. So we can go ahead and replace this with 2 over n. Now remember that SI for this type of problem is going to be equal to a plus I delta x. Now we know our A is 0. I is part of this summation, it's going to be left alone, and we know delta x, it's 2 over n. So this is equal to 2i over n. So now we have f of 2i over n times 2 of n. 2 over n. So now we're almost done setting this up. The last thing we've got to do, and we'll go ahead and move it down here, is figure out, well, what is f of 2i over n? To do that, you have to figure out what f of x is in this problem, which is this. F of x is equal to 4x. We'll write that over there. And we want to know f of 2i over n, so all we do is replace 2i over n for every x we see, which in this case is just 1. So we write the limit as n approaches infinity of the sum of I equals 1 to n of 4 times 2i over n times 2 over n. So we just replace this with this, replacing x with 2i over n. And that's our limit right there. So now we can start evaluating this. You'll remember in the lesson we talked about how we want to get this I by itself inside the summation. So what we're going to do is write this and bring everything that's, well, we can go ahead and write this. It's going to be, if you just multiply it all out, ends up being 16i over n squared. And now we're going to take out everything that's not an I and put it outside this summation thing. So it's 16 over n squared times the summation of I. Now in the lesson we talked about that we can find what this is in terms of in terms of n, and that it's just something that you'll maybe be given on a problem or have to look up, or but probably not memorize. They should give something like that to you, but for this BOP you can go back and look at that until you kind of remember what it is. And for the summation of I, we'll get what it's equal to in just a second. So this is equal to 16 over n squared times the summation of I is equal to n times n plus 1 over 2. So now we just multiply all this out. It's going to be equal to 16 n squared plus 16n over 2n squared. We'll simplify it again. It's going to be 8n squared plus 8n over n squared. So now what we're going to do is divide everything, each term in this, by n squared, because if we try to evaluate this right now, we'll get infinity over infinity unless we use some kind of method like dividing everything by n squared. So that's going to give us the limit as n approaches infinity of 8, because 8n squared over n squared is just 8, plus 8 over n over 1. We just divided each individual term by n squared. As long as you do it to everything, you're allowed to do that. So now we can evaluate this limit. We know that the limit of some constant over infinity is equal to 0. So now we're just left with 8 over 1, which is equal to 8. And that's our answer.